because...
Oh, there it is.
Yeah.
There it is.
The impression that there was an infinite source of energy might have been not necessarily what people wanted to do at the time.
What the Tao is describing is this fundamental unified field.
This is what Einstein described, the curvature of space-time, which he didn't say what space-time is made of.
Because we're all entangled
through this field. There is on our planet currently animals that are eternal.
How does an atom spin?
All right.
Where's the energy source that keeps all atoms spinning, all electrons moving? Where is that? Where does that come from?
Dude, I can calculate how fast the universe is thinking. Do not despair. There is incredible possibilities coming your way. Everything is there for us to make this leap, to make this step. Our kids will see an amazing world evolve.
Nassim Haramein is a certified genius, astrophysicist, quantum physicist, and he's here to set the record straight about the actual nature of the cosmos. And what was really beautiful about this podcast is we were able to bridge in some concepts from ancient Taoism, from Kabbalistic traditions, and see how they interface with the most cutting-edge equations that are coming out of quantum physics. And what we found was this beautiful synthesis of ancient wisdom and the most recent scientific discoveries. Things like at the center of the sun is a black hole, and the light that emerges is also originating from this void that's pulling in the energy and coming out, the cosmic battery that can be represented by the yin-yang symbol of light and dark, and how this interplay of light and dark works in the cosmos. And then how this energy, this boundless energy of the force, of that thing, the Tao that's older than God, that is the substrate of all unicity, how this interacts in the field of articulation, not only of planetary structures, galactic structures, but of our own personal structure. What is the energy that is at the core of every atom? We've been in this search for perpetual motion machines, but guess what? Atoms are already perpetual motion machines. They're constantly moving. Where is the source of that energy? And Nassim would say that the source of that energy is the source of all energy, source itself. This podcast is mind-expanding beyond belief, and it is with absolute great pleasure that I share not only all of this information about the cosmos, but a genuine message of hope in these times of chaos and turbulence for where humanity is headed and why it's going to be headed in a positive direction. So it is with great delight I share this podcast with Nassim Haramein. Nassim.
Hey.
I don't know if I've ever been so excited to talk to somebody on a podcast, because in following your work and studying and preparing for this show, I realize how little I actually know about the universe.
Thank you. Well, that's the state of the world in general, so don't feel bad.
Yeah, it's really remarkable how much knowledge is at the forefront that you've been able to access, and how little that has been translated into the general layman understanding of how everything was. Everyone just generally accepts, okay, in the beginning there was a big bang, all light compressed to the size of the tip of your finger, and then boom, here we are.
Billions of times smaller than the tip of your finger.
Yeah, right.
Planck-size object. Yeah.
Right.
Yeah.
That always made sense to me too. I was like, why the tip of your finger? Why wouldn't it be just a single micro point?
Yeah, singularity. That's what the theory says. Yeah, and I think it's significant actually that scale, the Planck scale, is a very significant, important scale that's overlooked in physics.
So explain the Planck scale, so for people who don't understand.
Okay, well, I would have to start with quantum mechanics. And I think it's important for people to understand quantum mechanics better, because there's a part of quantum mechanics that's very much publicized that has to do with the Copenhagen interpretation and how, you know, an observer or observation has to happen before the material world materialize in what it is and all this. And
so this is the observer effect, where they showed that if you're looking for particles, you'll see particles. If you're looking for waves, you'll see waves, which then allowed people to say the reality is dependent upon the observer's intention.
That's right. And that interpretation is known as the Copenhagen interpretation. It comes from a very famous conference that occurred there. And this interpretation, I believe, is completely incorrect. It's completely false.
All right. Shots fired right out of the gate. Okay.
And it's really important for people to know. And actually, students in physics should be taught that. For some reason, they're not. That there's alternative views that were given by very serious people, Duboglie being one, and Bohm, and that give all the correct answers with a very mechanical fluid dynamics view of the effect. And in that case, you don't have to invent really, you know, esoteric, ungrounded ideas that somehow particles can be waves and particles at the same time. And it basically, the only difference in the interpretation is to show that actually when a particle moves, it's moving in a field. So when it moves, it makes waves, just like a boat on the ocean. So it's a particle and a wave. Yes, but not in some esoteric way. It's just when it moves, it makes waves in a field because it's not in a field-free environment. Space-time, space is a field of energy. And actually, I demonstrate very clearly that it is the field of energy that makes the particle in the first place. So, of course, okay, so we can get into the double slit experiment, which is how this interpretation occurred. But I'm going to have to back up to the foundation of mechanics, of quantum mechanics.
I'll let you drive the ship here.
So if we want to talk about the double slit experiment, we can do that. I'm just going to give it quick interpretation. It's called pilot wave theory. And it just shows that, okay, so the experiment is like you got one slit and you're shooting electrons or photons at this slit, and you have a detector on the back, right? And you expect on the detector, you're going to get dots for each particle that hits the back detector, and the ones that hit in front of it won't be detected, right? The ones that don't go through the slit. But then you put two slits, and you'd expect that you'd get some particles going through the one slit and some particle going through the second slit, and you should have like dots on the backboard, right? On both sides, on both slits. But instead, you get an interference pattern, okay? And that was weird because it's like, what's interfering with the particle? So then it's like, oh, the particle is like becoming two particles going through both slits and interfering with itself. And like all this, like, I don't know what they were smoking, but it wasn't the good stuff. And it's like, you know, all of a sudden.
And what is the good stuff?
Well, yeah, well, that's another story. You know,
we just got back from Burning Man.
Yes,
so that gives somebody an idea that Nassim may know what the good stuff is.
I don't know, but I'm saying like it's a very strange interpretation. Sure. And then, of course, scientists at the time tried to like measure exactly which slit did the particle go through. And how is it that it's interfering with itself? And when they tried to put a measurement instrument there, they realized that when they put it there, all of a sudden they get dots on the backboard, so it changes the result. So then there is like the interpretation is, oh my God, when we try to measure it, which we have to make the distinction. That doesn't mean there's a conscious observation. Could be a measurement from a device that's just tied to a computer, nobody's looking, right? But when we try to measure it, we get a different result.
Mm.
And this led to a series of equations that describe this collapse of the wave function, of the quantum wave function that makes up particles. But if you take the analogy of the boat on the ocean, and when the particle is moving, it makes waves. Well, then when you have one slit, you get the dot because only the boat goes through. When you get, I'm saying this loosely, right?
Yeah.
Just so we understand, like it's more in depth than that. But and if you look up pilot wave theory, you'll get all the information. But if you have two slits, then the waves that the particle made go through the second slit and interfere with the particle and produce an interference pattern. And then if you put an object to measure what's going on there, if you add a measuring object, that object is making waves in the field.
Mm-hmm.
And it's canceling the waves that the particle is making.
Mm-hmm.
And now you get a third result. Mm-hmm. But it's not some esoteric thing that like there's an observation and it's changing. It's just a fact that everything is bathing in a fundamental field of energy that interacts with all things, mm-hmm. that connects all things. And so although the spiritual people might say, oh, but you're taking away this possibility that consciousness is involved. And I'm saying, no. First of all, in the standard model, there's no equations there that says anything about consciousness. It's not true that it predicts consciousness. In the standard model, it just says that the waveform is going to collapse into a random thing. Like it, could be anything. It's not tied to consciousness in the equations, right? It's just tied to a measurement. But more importantly, when you see it as pilot wave theory sees it, I discovered pilot wave theory independently in my van in the 90s, thinking I had figured it out. And then I realized that de Broglie did it like long before me. And so now you have something I think that's much more profound. You have something that says that everything is connected through a fundamental field. Mm-hmm. And so, let's jump back, because this is a part of quantum mechanics that is very specific. Let's jump back to the start of quantum mechanics.
Yeah.
And understand something really important there. And this is something, like if there's physics students listening right now, they got to listen really closely here, because this is the part of their course that they will not be taught. Okay? And it's really critical. So how did quantum mechanics start? It started with Max Planck trying to make a better light bulb. He was commissioned by, a group of different organizations that were trying to improve on the light bulb, because the light bulbs didn't last very long then. The filament kept on burning out and all this. And so Max looked at it in detail and tried to figure out the thermodynamics of this element that emits electromagnetic fields when you heat it up, right? So he was looking at it, and the equations of the time were saying something really weird. They were saying that the element should emit infinite amount of ultraviolet radiation, and that's not what we were measuring in laboratory. Mm-hmm. So it was called the ultraviolet catastrophe. So he tried to resolve it. And in order for the equation to work, it's called Planck's law, he had to add a little component, a little free parameter in some ways, that he called H bar, that actually it was H at the time, right? Mm-hmm. Eventually, Paul Dirac modified it, showed that it was an angular momentum, so it was H over 2 pi, and that became H bar.
Nobody understands that, but,
Okay,
but we'll continue. It's
yes,
okay. Yeah, we'll allow that.
Yeah, just so
so we
people
know. Yeah.
It's actually an action of an angular momentum. It's a little spinner. You could think of it that way. And what it did is that in the equation, it basically said that like the electromagnetic field that's radiating from the element when you heat up something is actually coming out in packets, little spinners.
Like pulses?
Yeah, like pulses, packets. It wasn't continuous.
Right.
Like quantas of energy, which were described by H or H bar later. And that packet of energy, eventually Einstein took that and said, hey, you know, I can explain the photoelectric effect with that. You know, so that like the little packets of energy are hitting electrons and throwing electrons out in semiconductors. And that is what makes, you know, like photocells that we use for, you know, solar panels. And he got the Nobel Prize for that, calling the little packets photons. And that's where the concept of photons come from.
Okay.
You see? So a lot of people don't realize actually Einstein didn't get the Nobel Prize for relativity. He got the Nobel Prize for contributing to the start of quantum mechanics. And so, you know, when you looked at this equation, Planck's law, it said that the universe, when it radiates electromagnetically, it's packets of energy that it's radiating, and it's absorbing packets of energy. The equation is describing an oscillator. Okay? That is the foundation of quantum mechanics, is the description of an oscillator. So you could think of it as a little proton, like the nucleus of an atom, or an atom being an oscillator, right? Like, and the problem is that, okay, so listen to this. This is remarkable. So when it's taught to students, instead of telling the student, visualize a little spinner, a little top spinning, that's an oscillator, right? They're told to visualize a spring with a weight on the end. They're mathematically mappable one to the other. So it's mathematically the same. Except that if you're thinking the universe is making springs with weights on the end, you don't have the correct image in your head of what you're actually describing in your equation.
Right.
And these type of analogies are very destructive to our capacity to actually understand the universe. Because we start, you know, making models in our head that don't have anything to do with reality, right? The universe is clearly not doing springs with weights on the end, right? Like a little spring that's oscillating up and down like this, right? And that's like critical that the students get the right visual. We're talking about something that's spinning. I mean, springs with weights on the end are made by the universe after they've made the humans that makes the springs and the weights. Okay?
Right.
But if you're trying to understand the universe, then you got to have the right image in your mind.
So if I'm trying to visualize this, and I think, you know, I'm picking up what I was able to understand from an interview that I watched you do. And basically what you're saying is this pulsing, oscillating pattern is that we're creating a new projection of reality, so to speak, in every Planck second, which is like the smallest measurement of time possible. It's the interval between these pulses.
Exactly. And there's a timing thing that's happening.
It's like boom, 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 but so fast. And
there's a heartbeat.
And it's
to the universe.
And it's almost infinitesimally measured, and it's creating reality in every Planck second.
Exactly. And then as you go up in scale, that timing slows down, right? Because it takes longer for a proton to make a a turn than to a Planck, which is billions of times smaller.
So a Planck is like a quark? Or is it smaller than a quark?
Smaller than a quark.
Okay, so it's the fundamental, it's the very basic unit that the irreducible unit is like a Planck.
It might be reducible to sub-Planck.
Oh boy.
But the speed of light limits. So you could say that maybe it's the fundamental pixel for our size universe.
Okay.
But it
may go all the way down
that's right.
infinitely.
Yes, because past the event horizon of a black hole, you have, it's called transplanckian problems, meaning you have things that would go faster than...
I mean, lots of people have transplanckian problems.
Yes.
Let's just be real.
That can happen. But that's a whole other story. It's really important you understand, I'm talking about this in a very rigorous way.
Yes.
It's not philosophy, okay? It would be philosophy if I didn't have equations to support what I'm saying. So if people
the philosophy comes after.
Yes. Well, actually, philosophy should come first.
And then the equations explain the philosophy.
And then you do the equation, and that's lost in physics currently. Most physicists just learn to resolve equation. There's a famous saying by Feynman, shut up and calculate. Don't ask questions. They're just doing math, and math can run you straight into a wall, right? Mm-hmm. Like string theory is a good example of it. And you have to have fundamental concept of what you're trying to solve. Otherwise, your equations can tell you anything you want, right? Yeah. And the only way you can verify that your equations are telling you the right thing is when you go to experiments and confirm that the equation is giving you the right result, right? There's no experiment in string theory, for instance, that can confirm anything because the equations output really like almost infinite amount of possibilities, right? 10 to the 500 different compactification of strings that like it tells you that like there could be one correct answer in 10 to the 500 answers, right? Like it's the largest number in physics. But in any way, let's not get off track, right?
Well, I want to do one thing here because we're going to get deep in the weeds, and I also want to share with people that you have a paper that you recently published that has an unreal amount of equations and grounding to everything that you're saying.
Right.
So, and I want to, help you and help everybody make this clear that this is not just you casually looking at this like an armchair physicist. You're actually deep in there figuring it out.
And I'm working with physicists from the biggest schools in Europe and and don't believe the goofy stuff on Reddit, that my papers are not peer-reviewed and all this. That is false.
Of course.
and
of course.
Right.
Anybody who challenges the dogma of the time is going to be ultimately attacked. This occurs in every different academic every different academic school. It's just it's the nature of it. Right.
And every large discovery. Were very fundamentally attacked. But and I don't say this in arrogance. It's just the way it is. Yeah. And it's analytical, so you can actually, if you got enough, you don't need that much math to follow these equations in that paper. If you're a good engineer and so on, you can follow this equation. If you're a student of physics, you can follow these equations, and the annex are there to help. We try to write it in the most, easy way to absorb for scientific, person with some math. But we try to write it as well historically. So we actually spend quite a bit of time in the first section in describing historically this oscillator that was described by Max Planck, putting back the spinner instead of the spring, right? And, solving those equations. You were gonna.
Yeah, so I want to. So you were saying that it starts with philosophy in some way, in some idea. And one thing about the creation of the universe that I thought was really impactful for me, it felt like a true philosophy. And I have my own anthro-ontology that is not entirely accurate, but I feel things as like, this feels like this is something that's true, right? So anthropos, your body, ontology, what is real.
Right.
And so when I read verse 4 of the Tao Te Ching, it says, the Tao is like a well, used but never used up. It is like the eternal void filled with infinite possibilities. It is hidden, but always present. I don't know who gave birth to it. It is older than God.
And that's great. And that's amazing.
And to me, that feels like what the Tao is describing is this fundamental unified field.
That's right. And that field, this is what the students will not be taught. Okay, that field was actually discovered by Max Planck while he wrote these equations. Mm-hmm. The Planck law has a little bit that was removed from it, okay, that described just what you read. Mm-hmm. Because, so now when you solve Planck's law for the internal energy of the oscillator, okay? There's a part of the equation, 1/2 h bar mu, or it can be omega, depending if you're doing how you write the equation, but which says, so let me back up. The equation says at this temperature, you get this spectra of heat. Okay, meaning at this temperature, you get this amount of energy from the oscillator, right? So you get a spectrum, right, of, and you see that when you buy a light bulb still, it'll say, 3000 K on it, right? 3000 Kelvin. That is the temperature of the light bulb, the energy radiance of that light bulb. Okay.
And I suppose you can measure that as heat or light, like lumens or kelvins.
Emission from the filament. Nowadays, light bulbs are made of diodes, so we have that convention to describe the color of the photons emitted by the light bulb still, but it's actually not coming from a filament anymore, right? Mm-hmm. However, this fundamental equation that describes this, so it got rid of the ultraviolet catastrophe problem. It gave the right answer for the ultraviolet emission and all this. When you solve it, it tells you, there's a part that tells you that at 0 Kelvin, so on your graph, on your spectra, 0 Kelvin would be like the ground state of the electromagnetic field, right? When zero emission should happen.
So that's the cessation of all energy.
Yeah.
At 0 Kelvin, there's nothing.
0 Kelvin's like, have you been to Canada?
I've been to Edmonton.
Okay.
Yeah, it's fucking cold.
It's damn cold, right?
Feels like 0 Kelvin.
Yeah. Well, it's not anywhere close to 0 Kelvin, right? And so 0 Kelvin is seriously fucking cold, right? So nothing should move.
Absolute. Yeah.
There should be no thermal agitation. There should be no energy. Mm-hmm. However, the equation, which gives all the right answer for the rest of the stuff, says that at 0 Kelvin, there's an infinite amount of energy. The equation diverges to infinity there. Mm. And
so it's almost like at 0 Kelvin, we're back to the Tao, which is completely full with infinite possibilities and infinite energies. Exactly. It's like a point of singularity.
Exactly. And you said the word singularity, which implies Einstein field equation. So let's hold that.
Okay.
You got the right idea.
Yeah.
Now you have but you say, okay, so yeah, so that means the ground state of the electromagnetic field is full of energy. Mm-hmm. Max Planck discovered this, he called it 0-point energy, 0 Kelvin energy, right? And so 0-point energy was like, oh, what do we do with the infinite amount of energy, right? Well, in general, now, was this done on purpose? Was this done just because we didn't know what to do with the infinite amount of energy, whatever? I would say probably a little bit of both, and I've done a lot of research in history of physics. You have to put it in the context of the time. We're talking, you know, First World War, Second World War. We're talking about, you know, looking for atomic energy, the atomic bomb being developed, giving the world the impression that there was an infinite source of energy that could be accessed might have been not necessarily what people wanted to do at the time.
Well, certainly not if you're a titan in the petroleum industry. You definitely don't want infinite energy if you're controlling the oil and gas and coal of the world.
I would say that might have been a reason later on.
Right.
But early on, definitely, you know, it could have been like on purpose derouted. But basically, what happened is that part of the equation was removed generally. Okay, it's not taught clearly to the, and if physicists that are listening to this might say, but no, I saw that somewhere. It's taught incorrectly because people think that it comes from uncertainty principle, which it doesn't. Uncertainty principle come from 0-point energy being there. But I'm going to tell you what happens when you remove it. Okay? What happens when you remove it is your equation now is describing an oscillator without a source. So it's spinning. So now let me ask you, your wheels on your car, which is an oscillator, right? It's spinning thing. Okay? Do they go anywhere if you don't put energy in it?
Only if I'm on a downhill.
Yes. Then you're using the gravitational field
yes.
to put energy in the system, right?
Right.
So that's called a gravitational potential. If they're on flat, they don't go anywhere until you put energy,
correct,
right? So you have to put energy in an oscillator for the oscillator to continue to oscillate, right? Let's go back to the spring and the weight.
Yeah, like how does an atom spin?
All right.
Where's the energy source that keeps all atoms spinning, all electrons moving? Where is that? Where does that come from?
Dude, they get on the case of people that have been working on what they call free energy or over unity devices all the time, saying you guys are trying to violate the laws of conservation of energy and da-da-da-da. This is a violation, like right in the base of quantum mechanics. There's a violation of the laws of conservation because your oscillator, go back to a spring and a weight, if you stop doing this, what happens? Does the spring continue oscillating? Yeah, for a minute or two, but then it stops, right? So the same thing, and when you calculate it, it's inconsistent mathematically, meaning like this field, okay, that's the 0-point energy is described as like constructive and destructive waves of the electromagnetic field, right? And if they can't, if that was all canceled out, it would be, technically, it's called commutative. The equation cannot be commutative, meaning it has to be non-commutative. That means there's got to be more energy that comes in to overcome the resistance of the oscillator to continue to oscillate. Right. Just like you have to put energy in your motor for your wheels to keep, against the friction and the weight that it's pulling and all this stuff.
So this is like a revelation that seems like right in front of our eyes. So there's been a quest to create a machine that could perpetually move, a perpetual motion
Yeah.
machine, which doesn't require additional energy
Yeah.
to add it. So you start the momentum, and then once you start the momentum, it goes infinitely, right?
Yeah.
Like that's been a scientific study, but it's happening all the time with every single atom.
Exactly.
It's in perpetual motion without the adding of additional energy. So the only thing
Did you ever receive a bill for it?
Yeah. The only thing that could possibly explain it is there's a source of infinite energy at the root of all of that.
And we found it. And then it was ignored. It's 100-some years later. Unbelievable. 30 years ago, when I was starting to present in physics conference, I used to talk to people about this, and they would say, but you're talking about perpetual motion. That's impossible. And then I would ask them, where have you seen anything else? Where have you? I'm not talking about you relative to a car. I'm saying the universe hasn't shown any evidence of stopping or slowing down. In fact, we know it's expanding and accelerating, which at the time we didn't know 30 years ago. Like that was found like later on in like the early 2000s. But this you know, like not only is it not slowing down, it's accelerating, but on top of it, we haven't seen one proton ever decay. The proton is the nucleus of an atom. We haven't seen one proton ever decay. We see protons together decay and radiate, but the proton itself doesn't decay. We've not seen that ever.
Yeah. You know, another interesting thing, and I apologize for these tangents, but as things illuminate in my mind, so we'll just take this slow. You know, the idea that if you split an atom, like in a hydrogen bomb or a regular nuclear bomb, it creates this massive explosion of energy. When they first started to do that, there was legitimate concern that it would create so much energy that it would destroy everything. In the splitting.
Ignite the atmosphere.
And everything, and it would just be the destruction of the whole world. So that's why if you watch the movie about Oppenheimer and everything, everyone was kind of a little sweaty, when they first had that.
Because when they pushed the button, there was actually a way you could write the equation to show, the atmosphere could catch on fire and we could lose the atmosphere.
And because at the core of everything is infinite energy. So if you somehow unleashed the core of everything, you would get the destruction of everything.
But that's the other thing. When you create fission, right? You're liberating massive amount of energy from a very small amount of matter.
Mm-hmm.
E equals mc squared on matter is a lot of energy.
Yeah.
And so this is remarkable. Where is this energy coming from? In the movie Oppenheimer, I was proud of them for at least mentioning, it's very quickly mentioned, that it's the strong force. It's the force that's holding the atom together that's being liberating.
Mm-hmm.
But the mass of the protons that make up that nuclei, right, protons and neutrons, is not given in standard physics. So I'm not going to want to get too technical here.
Yeah.
I will get back to the mass of the proton.
Mm-hmm.
But you have to understand that like currently, in a very non-rigorous way, the mass of the proton, which is the mass of matter, how matter has energy, how matter has mass, is not given in physics.
Mm-hmm.
It is no equation, analytical equation that says, it just says that it's the result of the strong force interacting, which is not, the source of which is not given. Yet, so this is what I did in this paper. I went through, I said, okay, you can't remove this 0-point energy. It's mathematically and physically inconsistent. Everything should have stopped a long time ago if there's no source to the oscillator, right?
Right.
And then I calculated with what's called correlation functions. They're equations that describe in a field of waves, like think of the surface of the ocean, how many are going to like cancel out and how many are going to be constructive.
Mm-hmm.
And because the equation is non-commutative, that means that there's actually, you know, it's not the same. A photon that's absorbed into the oscillator and emitted is not the same as a photon that's emitted and absorbed. So you end up with a positive energy.
A surplus, yeah.
A surplus. So I calculated the correlation function of this field for an object, and so you put in there like the correlation time. It's like the scale at which you're looking. When you're looking at the waves, there'd be bigger waves, smaller waves, smaller waves, smaller waves, right? So you put in there the scale you want to look. And when I look for the Planck, I got the Planck mass. But when I look for the proton, I got the proton mass.
Mm-hmm.
The whole thing.
Mm-hmm.
Showing that the mass or the energy of matter, which is the proton, right, is coming from this field.
Yes.
You see, this is remarkable.
Mm-hmm.
It's remarkable because the standard model has this whole Higgs mechanism, you know, that gives mass to particles.
Right.
They called it the God particle, right? They spent some $13 billion building accelerators to find it. It costs $1.5 billion a year budget to keep that thing going. And, you know, and at the end, the Higgs mechanism in the standard model is only consistent inside the standard model. When you go to experiment to verify it, right, for the proton, you're predicting less than 1% the mass the proton, 5 to 1% the mass the proton. And then if you add that to the fact that we're missing 96% the mass in cosmology, then you're only predicting like 0.1% of what we see, right?
Yeah. Okay. So this is coming to me here, and I need to I need to step back to something you said.
Okay.
You said the universe is expanding. So
yeah.
The universe is both mass, light, energy. So would that be correct to say that the universe is energy roughly in different ways?
In different ways. It's 99.9% plasma.
Okay. So
whatever is not plasma is plasma that's cooled off.
Okay. So if it's expanding,
yeah.
then there's something beyond the horizon.
Very good.
There's something beyond the horizon. What is it that's beyond the horizon that we're expanding into? What is that? Is that
most likely a larger universe?
Whoa. Okay. So we're expanding. It's a universe of a different type?
No, just a larger universe. Think of a galaxy inside our universe, right? It expanded from a quasar, you know, like it became a galaxy expanding inside our universe.
So, okay. So then when the Tao Te Ching is saying that the Tao, which is the unified field of all universes must come from the unified field.
Right.
So all universes maybe we say God is our universe, right? And they say the Tao is older. than God.
Then they must be talking about the universe our universe is in.
Yes.
That's right.
They're talking about the great universe.
Right. Which is probably in a larger one again, and a larger one again.
Infinite, but that's all still the Tao.
So, yeah.
Yeah.
So now you have the concept of fractality, singularity.
Right.
Right.
So God is describing our universe. Our universe is all contained within the substrate of a unified field that we call it the Tao. Yeah. I like to call it the force, but whatever that is, we're just one fractal of that.
That's right. And that field of energy, it's coming from all these oscillators. Think of our universe as an oscillator. It's spinning too, and everything in it is oscillating. The field of energy has got all these oscillation in it.
Infinite possibilities.
That's right. Infinite oscillations.
Yeah.
Infinite amount of energy. Infinite amount of energy. And even if you just say, okay, well, I'm going to cut it off at the Planck scale because that's the speed of light, whatever, you know, like we show in the paper that there's a good reason to use the Planck scale as a cutoff. When you still have 10 to the 93 grams per centimeter cube. So if you took all the stars we see in the universe and the black hole, everything, and we stuck it into a centimeter cube of space, we would be 39 orders of magnitude not as dense as 10 to the 93 grams. You know, so it's like insane amount of energy is present in each centimeter cube of space.
Wow.
And that's what's running our world.
Yes.
And
yes.
and it's been there for 100 years in our equations.
I had a vision in an Iboga journey where I was, you know, communing with spirit. And we talked about this before. You get access to information and then you always translate it through a hermeneutic prism of your ability to understand. And these medicines, these sacred plants, they open up a window to try and give you something that you could interpret in a way. And this thing that I saw, this vision that I saw that I'm going to explain was in many ways beyond comprehension to me at the time, because I asked, what is the nature of God? Right? What is the nature of God? And it showed me the image that it showed was this giant blue Titan. It was like this Titan figure. It had its own kind of anthropomorphic kind of image that came to me, but I don't take that super seriously. It was just, that's what it was showing me. I was like, okay, God is this giant Titan. And then Titan was moving on an elliptical track, like a racer in the Olympics, whatever. You're moving around. Yeah. It was moving around a track. And I was like, okay, so God is moving infinitely around this track, spinning like an oscillation.
That's right.
And then
that's called circulation in fluid dynamics.
Okay. Yeah. All right. So vision's tracking so far.
Yeah.
And then it showed me that there was an infinite amount of these titans, these gods that were also all running around the track. And then I was like, what the hell does this mean? But now it's starting to make sense that the track is like the unified field and God as a universe is just one of many universes spinning around this elliptical track.
That's right. That's right. And what's making it spin around, right? What's holding to the center?
The Tao.
Gravity.
The gravity. Okay.
It's like gravity.
Yeah.
And so we've been talking about quantum mechanics. On the other side, we have equations that says that space-time curves to produce gravity when there is a presence of energy or mass. Right? So that side we haven't discussed yet, but it works into this, right? Because when you write this, when you keep the source of energy for your oscillator and you write this properly, you inevitably arrive at general relativity. And so that the detractors out there say, oh, but he's using general relativity. It's a natural consequence of writing the equation. And they comment, you can't use relativity at the quantum scale. Oh, yes, you can. The universe is not like confused about the state of gravity, just the humans.
Yeah.
Right.
So, and in this way, you can imagine, okay, so we have planets rotating around the sun. Sun is rotating around a galaxy. The galaxy is rotating around, like everything is orbiting. And so the universe... Some central point. And so the universe itself might be orbiting
a black hole.
A black hole at the center.
A singularity at its center.
At the center of everything. Yes. And then there's many other universes all
orbiting a larger one, all orbiting a larger one, and so on. Yeah.
So somewhere at the center of
And you can go
centers.
down. Yeah, you can go down, all the way down, past Planck, all the way down. And I wrote these equations and I found the scaling, the coupling of all these oscillators inside each other. I found how it couples. We measure these things empirically. It involves the gravitational constants that we measure, the Rydberg constant that we measure, all these things. We measure these constants. We don't know where they came from in physics. right?
Mm-hmm.
This puts it all together. You start to understand, oh, that's why G is G. That's why, C is C. That's why it all starts making sense. Why values that we measure are highly tuned for our universe to work, because it's the mechanics of how it works. And it eventually emerged life from it. And this is a really powerful part that I just solved 2 weeks ago, because I just didn't have time to apply to biophysics, but I did a few weeks ago. I'm really excited about it.
Mm-hmm. So life and light and and anything that we can measure, matter, life, light, this is actually a reduction of the possible energy of the unified field, right? Like it's like a partiality of it.
It's a relationship. It's a coupling. It's called weak coupling. Across scale, if you have something that's spinning, right, that's really small, if they get together, the spinners, and they become coherent, so these equations, the correlation function, they describe how much coherency there is at each scale, how many of the spinners are contributing their energy to that scale, right? So more they're coherent, more they're going to contribute, right? Let me give you an analogy that might make it clearer, okay? You're in your bath with your rubber ducky, as you do.
Always.
Yes.
Never without.
That's right. And you pull the plug.
Okay.
If you bring the rubber ducky close to the drain, it will appear like it's orbiting, right?
Right.
And it appears like it's attracted to the drain, right? And if you put it away, far from the drain, then all the water is chaotic, so it's not going anywhere. But in the region of the drain, the water molecules are coherent. They're all co-moving in a coherent way. And if you look at the surface, you can see it curve. This is what Einstein described, the curvature of spacetime, which he didn't say what spacetime is made of. Although at the quantum level, we had that field of infinite. So let's for the listeners, non-rigorously, I did it rigorously, but just so we understand each other, let's put space-time and this fundamental zero-point energy field together, right? It's one thing. And so he described the surface of the water curving, creating gravity. Where there's energy or mass, space-time curves and an object rolls towards it, right? That's what he described. But that's a secondary effect in your bath. The real effect is that all the little particles of water are co-moving together. See, that's the quantum size objects. This is why quantum physics and relativity have not been unified. Because one is describing a smooth surface curving, and the other one is describing little packets in a coherent. And so I put it together because it's kind of obvious, right? But so what I'm saying is that to understand, like, everything has a center and is spinning or is orbiting this center.
Right.
And it's because the flow of this fundamental field is coherent in that region. Just like in that region of your bath, it's coherent because there's a gradient, there's a density gradient. So it's like, and now you can use fluid dynamics equation and look at it. And you'll find that it has like very specific geometry, like a toroid geometry. It's going to flow out at the equator. It's going to flow in at the poles. And, it's going to have a very dynamic, and each scale is going to influence each other scale. So then now you can calculate the impact of a smaller scale on a larger scale, the coupling of these scales. And all of a sudden you find all of the correct coupling constants, all the correct values for the force we observe, the constants we observe, and all this, you start to understand that it's like a huge fluid dynamic structure that we're embedded in, right? That has infinite potential. Like it's remarkable.
All right. So let me see if I get this straight. So at the center of every atom is like a drain, which is like a black hole.
Right.
And everything is circling. Singularity. Everything is circling around this black hole.
That's
and then
right.
everything, and so as you get larger, we were talking before the podcast about the sun being a black hole. Well, of course, if that's like the drain,
right.
Even though it's emitting light, which is also, kind of mind-boggling because we don't think of a black hole as emitting light, but anything that's the drain that anything is circling around is like a little singularity, a little black hole.
That's right.
And then there's fractals of it. So a galaxy has its own center drain, and when the universe has its own, but all the way down to the atom.
That is so good. But there's so much in what you said that needs unpacking for a physicist listening to it. But it's absolutely correct what you're saying.
Mm-hmm.
It's very, very good. Basically, you can't. So remember, you have infinite amount of energy and energy curve space.
Yes.
In Einstein field equation. So that means that every point in space is curved to infinity.
Right. Because at every point is this singularity.
It's infinite amount of energy.
Yeah.
And so that means that every point in space is a mini black hole.
Mm-hmm.
Right? Mm-hmm. At the Planck scale.
And then there's just different magnitudes.
That's right. Exactly. And because there's going to be different moments where the spin, how you get Coriolis forces and centrifugal forces when you spin something, right? The spin that's pulling away from the singularity and the force of the singularity are gonna be in the right balance so that it produce a bubble.
Mm-hmm.
It produce an horizon, and one of those bubbles, so when the strength of the 0 point is able to like pinch space-time and make a first thing, is the Planck scale.
Mm-hmm.
And then again at the proton scale, and it makes scales, and we figured out that scaling factor. So now, and it gives the right answer. It gives the right mass for the proton, right energy, the right mass and the right energy for the electron, and planets and stars and galaxies. It does all the right thing.
Mm-hmm. All right.
And the idea that a black hole is just something that just sucks everything in is completely false. It's a fallacy of misinterpretation of Einstein field equation.
Mm-hmm.
Because Einstein didn't solve his own equation. When he wrote these equations to describe like how space-time is elastic and it's curving, he didn't solve that. That was too hard to solve. An amazing mathematical physicist that was fighting on the Russian front got a hold of Einstein's paper and said, I can solve that, and solved it, while fighting on the Russian front and being sick, and he died 2 weeks later. And it's called the Schwarzschild solution. Carl Schwarzschild solved this. It was the first exact solution to Einstein's equation, because Einstein's equation were written in a very difficult formalism. There's much better formalism today to use to solve Einstein field equation, but it's not very much use, and I'm not sure why exactly it's not very much used. But in any case, he solved this. It's called the Schwarzschild solution, and he sent it to Einstein, and he said, hey, your equation predicts a singularity. So Einstein was very, distraught about that, because it said that that his equation predicted that all the mass would be in the center, and it would curve space-time to the point that light could not emerge from it. But when Schwarzschild solved this, he solved it for a non-spinning, non-charged object to do a first level approximation, and then he died. So the spin and the charge didn't come till the 70s, right? So the interpretation, Einstein was discouraged because he thought, well, my equation probably predicts something that's not real, because he didn't believe that there would be something so massive that even the escape velocity of light could not emerge from it. And that's how the concept of a black hole, which was Wheeler that called it that way, came out, right? Well, that's all true if, the black hole is not spinning. And it's not true for anything past the black hole, meaning anything past the horizon. Like the equation predicts a radius, right? This is the radius where light cannot escape anymore. But there's stable orbits all around the outside. There's even stable orbits that have been shown inside the black hole. Okay.
Yeah, so there's fundamental ideas about the black hole that are misunderstood.
False.
All right.
The idea that they're just absorbing everything. So imagine you have something that's spinning. It's black holes spin at the speed of light. Okay, particles that are falling into a black hole spin at the speed of light. They fall in they eventually reach us. Imagine as they're going in, the centrifugal forces, how strong they would be long before they got anywhere close to the event horizon. The thing gets spit out. So actually, for things to fall into a black hole is very difficult. They have to approach very specific angles from the poles to be able to fall in.
Yeah.
Otherwise, they get spun out.
And presumably, when they go in, they come out in some other form, in some other way.
Well, they get shredded, whatever. They get transformed, yes. But more importantly, when I started talking this way 30 years ago, I then predicted that in order for a galaxy to exist, there must be a black hole in the middle. Or for an atom to exist, there must be a black hole. But that was already so much controversial. But I predicted there would be black hole at the center of all galaxies we observe, and that's what we found. Now, if black holes were objects that are just swallowing everything that's around them, galaxies wouldn't exist.
There would be nothing.
Right. There would be no galaxies.
Right.
Right.
Because in the essential nature of a black hole is the infinite energy of
vacuum fluctuation.
Yeah, and what we're calling
and so that hasn't been put together. They solve Einstein equations and they solve quantum physics in different ways. 0-point energy was removed anyway. Like, it's not put together. A black hole is just the 0-point energy in that region of space spinning. You see, think of a smoothie. It's the smoothie universe.
Right.
Space-time, like this fundamental energy, when it spins in a coherent way, like in your bath at the drain, it produces an effect we call gravity.
All right. So is there any place, and I use place in a kind of, I know it may not be a place because we're talking about time and dimensionality and whatever, but and words get complicated to try and explain it. Is there a place or any element or aspect of the universe that is not spinning? Is there a place where actually there's stillness?
Oh, yeah. There's a place where there's stillness at singularity. At
singularity,
when you solve for all the modes, they all cancel out. Like all the spins in infinite amount of universe, you could cancel out to zero spin.
To stillness.
But that would still be, a cutoff. Because you can't, you can't solve for all the modes, right? So, it would be like enlightenment, right? Where you have access to the whole, right? So in some ways I could say, yes, this is stillness at the center of spin, just like the center of a hurricane.
Yeah, the eye of the hurricane is more still than the other. Yeah.
No wind, right? You're in the center of the hurricane where you'd expect maximum wind, right? No wind. and then right on the edge of the eye of the...
And then everything starts spinning more. Yeah. All right, so I'm going to take you back to another mystical tradition that I've become aware of, and it's deep in the study of Kabbalah, which I'm in a deep study. And there's a concept called Tzimtzum, and this concept is about the creation of the universe. And what it basically is alluding to and pointing to, and there's some interpretation here to get to this, but the concept of Tzimtzum, which has been written about, is the idea that at the beginning of everything was not actually this expansion of light, but actually there was a unified field that was completely full. It was completely full of all possible energy. It was full. And in that way, you could say still, because it's full. It's absolute. It's absolute. So in order for there to be articulation of different spectrums of light, different spectrums of sound, different energy, Tzimtzum was described as a great in-breath that created, it actually pulled energy or pulled something from the fullness so that uniqueness could emerge.
It encapsulated.
Yeah, so it pulls in it's an in-breath that pulls in some of the fullness and then allows articulation to then spread back out into unique fullness.
Right. Because in a fractal infinite universe, each point is the center.
Okay.
So each point observes the universe from its own center, right? Like you're a human, I'm a human, right? But we have different retinas, we have different, fingerprints. Not one human is the same. Not one snowflake is the same. Each point expresses itself from its own center. So it's observing. You don't see the same thing as I see because I'm looking at this side of the bottle. You're seeing that side of the bottle. Because we're in different coordinates, we're different center, we observe from a different perspective. So we gather different information. We feed to the field different information. So the field makes us different. So it's an individualization. As soon as the energy can close up space-time and make a particle, it's made a point of reference that's observing from its own perspective.
So in this idea, what's coming to me is the idea of Atman and Brahman, right? Brahman being the everything in its totality, aperspectival, right? Like it's just the totality of everything as far as I understand the idea of Brahman. It's the whole thing aperspectively, just. And then Atman is our own unique participation.
That's right.
In that. And so we see, so our universe is different than every other universe because we're actually our own unique perspective of the whole universe, which is Atman. So we actually have a perspective, and then Brahman is the perspective that's aperspectival and sees everything.
Yeah, very good. And I mean, and you can think of it even that like when you start thinking this way, then you're getting closer to actually putting the things together to unify physics, because you're starting to talk in terms of information, right? You're talking about a point holding a set of information that's different from all the other sets of information. So now you have distinction, you have points of information interacting together, an exchange of information. And so now you can start calculating in terms of information, and when you do, you get the right answers.
Right.
It's remarkable because you can talk about it in philosophy, but then if you can write the equation, now you have engineering. You understand how the universe works fundamentally, like analytically. And now you can start making technology that works the same way.
Right.
And now you have technology that's vastly more advanced than what we have today.
Which is possibly and most likely what these alternate star system civilizations, which I fully believe exist, have been able to access, which explains the phenomenon that occur about how these ships travel and how these
things flying in our
travel.
atmosphere.
And even in the vision state, like non-material beings that appear, you know, they're traveling in a different way through a different energy source, this quantum kind of energy source.
They just tapped into the fundamental energy source of creation. So, and since it's curved to infinity everywhere, it's already all wormholed. It's already, this is why there's entanglement. We measure in laboratory. Quantum mechanics told us that, you know, actually Einstein wrote these papers with Rosen and Podolsky, showing that like quantum mechanics must be wrong because it's saying that like things could be entangled across the universe, right? That like a particle over here, if I changed it, it could affect a particle on the other side of the universe instantaneously. And he wrote these papers trying to disprove quantum mechanics or that interpretation of quantum mechanics. But in 2 months, he wrote another paper showing that, oh, even in relativity, you know, they could form, space-time could form wormholes that connected 2 points in the universe instantaneously. And most physicists didn't really understand what Einstein did there.
Yeah. And most, I mean, they call it spooky action at a distance, right? Because spooky, because it's like, what the fuck is going on here? Because
we don't understand it. And people didn't clue in that actually Einstein tried to solve that problem with wormholes. They think that he wrote 2 papers independently, although the writers were very much the same people, right? It was Rosen and Einstein for wormholes and Rosen and Einstein and Podolsky and for the other one. And so, but this not, you know, like he was trying to understand this, like, wait, space-time is like a fabric that's like networked, you know, and he wrote it for particles, not for black holes in the universe. He was saying particles seem to be like wormholes, black holes, network.
So a wormhole to me, if I'm understanding what a wormhole must be, it must be just a way that things connect through the unified field.
That's right.
Right.
That field, that 0-point energy fluctuating field, is like has structure to it that connects like all, it's like the black holes are the hub and the wormholes are the wires that connects the hub of the network.
And there's basically infinite wires.
That's right.
And infinite wormholes.
And the wormholes are Planck scale.
Right. So they're the most micro wormholes.
Right. And when information go through, cannot be Planck scale. So it's hyper-Planckian. It's sub-Planckian.
Yeah, because it's in the unified field at that point.
Yeah, and so because we have the scaling now in our equations, I can calculate the speed of the sub-Planckian field.
Whoa.
I can calculate how fast the universe is thinking. We think it's instantaneously by, you know, the measurements of entanglement. But that's because we can't measure very fast.
It's so fast.
It's faster than the speed of light by 10 to the 40th orders of magnitude. So because you see, if the whole thing, this is another thing that's very prominent in ancient civilization. It says that the whole thing is network and organized. It's not like that chaos is only a perspective, right? If you got your nose in the rug, you can't see the pattern. You think it's chaos. But if you back up, then you start to see the pattern, right?
Yeah, the whole mosaic.
Yeah. So then because if the whole thing is network, that means this feedback of information through this network, right? Then the universe has to be like updated every, you know, instant, right? By entanglement. And so I calculated at the speed of light, the universe would break down. Like, you know, it would take billions of years for information to go from one side of the universe to the other, so that everything could be in the correct order of a relationship.
So this is.
Let me just finish.
Okay, yeah.
I calculated at the sub-Planckian speed how fast the universe is updating just for our universe.
Which is like the pulsing.
Yeah, the pulsing.
Right.
and it's updating at 10 to the minus 22 second for information to go from one side of the universe to the other.
Okay.
And it just happens to be the time that it takes a proton to do one turn. You see? You see how
so it's all based on the
it's all relationship of oscillators.
So there's a lot of esoteric and spiritual teachings that say there's a place or dimensionality beyond time. And I think they use entanglement, and I've seen this used, and I'm not saying it's correct, but they use entanglement to say it's instantaneous.
Right.
But it really didn't make sense to me, instantaneous, necessarily.
What does that mean? It's used in physics. What do you mean by instantaneous?
Right. And what you're saying is it's not instantaneous, that time and space are connected.
Right.
And so there is no space without time. There's no atemporal existence.
That's right.
It's just going down to such an infinitely fast speed that it's almost immeasurable.
For us, definitely, even information going across the universe would look instantaneous.
And so as long as there's differentiation of any sort, because in the stillness is absolute singularity, right?
Right.
And there's stillness where everything is just one, so there's nothing moving, and there's no memory, there's no time, and
that's at the center of everything.
That's at the center of everything.
Yeah.
But everything else, it's just scales of time.
That's right.
That makes way more sense to me.
And even deeper than that, time is not a fundamental concept. Viewed from this perspective, memory is a fundamental concept, right? So no memory, no time. If you don't know what happened before, you can't see an evolution in time. Do you see what I mean? So I changed the word space-time for space memory. So I have a paper out called, Space Memory Network. That's a biophysics paper that got cited, actually better than my physics papers. But so basically, if you look at, so think of time is really just different sets of information in coordinates along a line. So, for instance, think of the Earth spinning around the sun, right? So we keep thinking that the Earth spinning around the sun is like going around in a circle. That's false, right? That should never be taught to students. It's incorrect. The sun is moving in our galaxy, and the planets are spiraling as the sun is moving through the galaxy. We're like billions and billions of, kilometers away from where we were last year. And as we think of it as like we're leaving information in the structure of space, in this network, as
creating a record in the Akash.
That's right.
Which is the grand memory bank of all things.
Which was known by ancient civilization.
Right.
And that is actually memory. Even the memory of your mind. Like your memory is you accessing information that was left in these coordinates when you were young, for instance.
Yeah.
And so it's malleable, meaning you can change it. Okay? And so that's not prohibited by Einstein field equations, by the way. But what I'm saying is that it's better to think of time as information. In coordinates in space. And so basically, when a bit of information leaves one side of the universe because you've changed the state of a particle, it's information that is transferred to the other side. Do you see?
Yeah.
And the time it took is just the entropy of this information having to go over there. Do you see?
Right.
And this entropy, this little energy lost, is what we call mass. It's actually the energy of creation. So the whole thing is thinking, and as it's thinking, it's making matter. It's making creation.
It's thinking / remembering,
right?
And record. And so that would be that entity, if you wanted to call it that, that is the ultimate memory, would be, you could call that God, I suppose.
Yeah, you could.
Yeah.
It's just I'd rather not use that terminology
because that word means so many different things for
to so many
people.
different people, and you don't have to. You can rigorously, physically, actually understand the nature of the universe. You can. It's not something you absolutely can. And it's hard for people to believe that. When I talk to physicists, just recently, a physicist at Burning Man, it's like, how can you be so confident? Because it's analytical. It's straight up analytical, and it works, right? It's not all published. I've published, this paper is a series of 3 that are coming out, and there's all kinds of papers that are going to extend from that. I'm working on a biophysics paper right now that I was telling you I'm excited about. Because when you do the scaling, you actually end up with microtubules in the brain. When you do the scaling, you realize that you can actually, microtubules are like the wormholes at the biological scale, if you'd like. Right? Which is the structure in the neurons that are like exchanging information that you call thinking. Right? So you can actually extrapolate to biology and why biology becomes coherent. Like, why is there coherency? You're made out of 100 trillion cells, 50 to 100 trillion cells. And each one is made out of 100 trillion atoms. That is complex, seriously stressful level of coherent behavior.
Because the universe desires coherency.
Right.
It desires ever greater intimacy and complexity. There's a desire at the core of the cosmos.
The system is self-interacting, so it has feedback.
Yeah.
So it will self-organize into higher and higher level of coherency. But our current theories have only noticed the decoherency. We've only looked at the radiation part, not at the collapsing part, at the part that's going into coherency. It's like we've only looked at the water going away from the drain, not the water that's falling into the drain. But in order for decoherency, in order for entropy to occur, there must be centropy. There must be neg entropy.
So are you starting to talk about this forces of polarity, whereas there's some expanding, like light expanding, and then there's another force pulling, like the antithesis of that
which is gravity.
Okay.
Yeah. So I'm showing you. So put it back into the Planck plasma. I call it this field, the Planck plasma. But it's this Planck. And imagine all this smoothie of it's billions and billions of Planck just for a proton, right? It's trillions of Planck. And when you calculate the energy of all these Planck, you get the exact mass of the universe, by the way. So we're clear. In the proton, when you calculate the mass of all the little Planck spinning, you get the mass of the universe. And then when you calculate the radiation energy of that black hole, you get the standard mass that we measure. But I want to say, so imagine that's spinning, right? And there's, think of this fluid dynamic Planck plasma is radiating out at the equator. That's the electromagnetic field. And the stuff that's going back in, that's falling in, the circulation of this Planck plasma. That's why when you said this track that the God was on is circulation. When you write this equation using circulation, when it's circulation, then you get the right gravitational field that we measure at the proton scale that's holding the nuclei together, that we call the strong force or the color force. You get the right value.
Right.
Okay.
Yeah. Okay. So you
have a flow out and you have a flow in.
And that's the polarity. So for every out, there's an in.
There's an in. Exactly.
Yeah. And those forces are in dialectic tension, so to speak.
That's right. At the horizon. And that's why you've created a bubble, whether it's a proton or a star or a galaxy.
Yeah.
And if you tell a physicist that the sun is a black hole, he's going to tell you, no, that's false. Why? Because he's solving Einstein field equations using the Planck, the Karl-Schwarzschild solution, which is, It's funny. It's really funny because whenever you use Einstein field equation, and we use it to describe the dynamics of planets spinning around stars or whatever, every time you do that, you make a black hole with the star, you make a black hole with the planet, and then you get the right answer. Every time you're using Schwarzschild solution. Every time. People don't realize that. They get taught the equations. They don't think twice. They use this. They've made a black hole with the sun and a black hole with the planet to get the right answer. And so so why is he gonna tell you it's not a black hole? The star is not a black hole. That their sun is not a black hole. He's gonna tell you that because if you solve for the mass of the sun with Schwarzschild solution of Einstein field equation, the radius of the sun would have to be like 18 kilometers. It shouldn't be what we see, right? But that's assuming that the mass, man, they don't understand their own equation. Like, listen, the equation says that at certain density, light could not escape anymore. It's a density equation. If you assume that the density is homogeneous throughout the sun, then, of course, it can't have that radius and be a black hole. But you could have a black hole inside the sun that has the correct density for it to be a black hole, right? And then a space, and then the plasma that's spinning around it, just like a galaxy, right? And the plasma mass plus the black hole in the middle is the mass of the sun you observe, and you would have no idea. Either then two things that we measure that would give us an idea, and certainly give me an idea, okay? One is that there would be region on the surface of the sun that would like where matter would like tend to want to fall in, right? And it would make like spots where it's really dark because photons would be sucked in and plasma would be sucked in and all this. Do we see that on the sun? Of course. They're called sunspots. Some of them are like 14 times the size of the Earth. They're not small events. They're huge vortices on the sun, right? That are absorbing material. And out of these holes, sunspot, radiation comes out, okay? X-ray. It's the highest level of X-ray, right? This is exactly what you expect when particles falls into black holes.
So if you imagine a sun and you applied the yin-yang symbol from Taoism, right? Which is, and of course it's designed in a flat thing, so it's not exactly I think accurate from a physics perspective model, but there's the black part of the symbol, and then there's the light part of the symbol, and you could imagine that there's the black part then would be the black hole, the sucking in.
That's right.
The white part would be the expanding out of light, but each sun is like a little yin yang. Each atom is like a little yin yang where there's
very good.
Where there's
I love your mind, man.
Thanks.
It's remarkable. You do very good because those concepts are complex. But you know, this is why I made a 3D rendering of the yin yang, showing it was a torus for the white part to be in the black, and for the black part to
yes,
it had to be a torus in 3D. That's why I did it.
Wow, I didn't see that.
Yeah, I'll have to show you.
That's very
it's
cool.
Cute.
That's very cool. I've realized in my own study of myself, I also, you know, if I think of myself, let's say I'm a planet or whatever, there's a part of me that's the light, the life that's emitting.
Right.
And then there's also a part of me that I call anti-you that's actually sucking and actually like pulling against me.
Centering you.
Yeah. And it's like pulling against the expansion.
Yeah.
But also necessary for the creation of who I am.
If you didn't have that center, you couldn't exist, right? Like all the masters talking about go to your center. Be in your center, look inside to your center, like
which is then looking back into the unified field and seeing the force that connects everything,
and the spin that radiates you every day, right? Because you're burning carnal energy, like you're burning like at 100-degree Fahrenheit all day long, 7 days a week. And if it varies by a few degrees, you're having a really bad day, right?
Yeah.
It's got to stay pretty steady, right? Nonstop, right? It's significant amount of energy. We can get into that, but I'm going to give you the second evidence for the sun, which is more recent. When we measure the gamma ray emission of the sun, it's nothing like it should be. Like we're measuring way too much gamma ray emission of the sun, and if you calculate how much, like what would be the source of such gamma ray emission, you'd have a black hole in the middle. And so these are things, and there's other example. There's the neutrino issue. There's all kinds of things, including, this is really important, including that when we see a star explode, and people think it's very rare that a star explodes. It's not. Like, if you look at galaxies, it's like Christmas lights in a galaxy, boom, 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 boom. It's constantly blowing. The stars blowing their envelope continuously, and when we call it the death of a star, or it's called a supernova, right? A supernova explosion. What do we find after the star is dead? We don't find like, oh, there's nothing there anymore because it just blew all to shredderings. That's not what we find. We find a pulsar or a black hole in the middle. Pulsar is basically a black hole, and we, and then people are realizing, oh, they call it a pulsar when they're looking on the side, but if they look down the poles, they call it a black hole, Anyway, so you're finding a super energetic black hole structure, and we have this completely reverse in astrophysics. We think that it's because the star exploded that there's a black hole. As if, an explosion, it would have to be absolutely, completely symmetric. It's not possible for an explosion to produce a black hole. The black hole was there first. That's what made the star. A black hole is the spin of the quantum vacuum energy in that region of space. And then it gathers matter, it makes matter, right? Because it's making smaller spins, right? That we call protons. And then eventually it gathers enough material so that it lights up. Right? Because there's enough energy, there's enough friction in the system, there's enough fusion that the thing lights up.
Ignites and it goes. So it's actually creating more and more energy from the 0 point field, more and more and more energy until finally it can't hold that energy. And
it drags, it starts dragging on space-time so much. And there's the carbon cycle that we observe in our sun where, the outer layers start cooling off and they start making a shell. And then the energy builds inside, and then eventually, bam, it blows. And when it blows, it puts material everywhere in its vicinity, right? This material reorganizes on smaller vortices of space-time, right, of the vacuum fluctuation, and makes planets. This is why the first exoplanets we found, planets outside of our solar system, we found them around pulsars. And everybody was like, how can they be planets there? Right? It just blew up. Like, how can they be planets? That's because, and as well, this is why we're missing 80% the mass of the galaxies. We have to add dark matter. This dark matter, dark energy thing, it's just because we haven't calculated the quantum vacuum energy and the dynamics of such a thing inside the galaxy. As soon as you put that in, you get the right answers. So, basically, it's the smoothie universe. You just got to think of it that way. And then you can start to see, earlier on when I was presenting in physics, they were telling me, planets are probably extremely rare, and because of their model, and from my model, I was saying planets should be around almost every star because they go through this cycle of blowing material out that reorganizes in planets. This is why all the material we see in our solar system, we know came from the sun, right? This is because, you know, the protoplanetary disk we are in. The other thing they notice is that, oh, it's bizarre. Our sun is in the middle of this bubble of nothing. That's because, and they say, well, there must have been a supernova explosion near our sun that moved everything out. And it's like, no, if there was an explosion, a supernova near our sun would have been moved out with the rest of the stuff. It's our sun that has gone through one of those cycles. Right? And that has made planets. And so I predicted there would be planets around pretty well every sun, every star. And that's what we're finding. And we're actually having a hard time finding stars that don't have planets.
Right.
And we're having a hard time explaining why we're finding supermassive, very mature galaxies and black holes at the beginning of the universe. Because now with our telescope, we can see almost to what we call the Big Bang, right? And we see huge black holes and galaxies that are in the standard model should not be there. But that's because, of course, it is the source of the galaxy, not the result. It's the source of stars, not the result. It's the source of matter, not the result. You know, mass is generated by this fundamental field.
Is there such a thing as like anti-mass or a vacuum that is the antithesis of mass itself in some level as you kind of balance the equation, right? So if there's something that's in articulation, then there's something that's in the antithesis of that articulation?
Yeah,
Would that
the
be
electromagnetic field is what you could call anti-mass, right? It's what radiates out. And that's why photons have zero mass, right? It's what radiates out. So when it radiates out, when the Planck field, when this fundamental field is moving out, it's going towards zero mass. And when it's going in, it's going towards infinite mass. You see? And then if you I'm trying to get this in words.
Of course.
That
of course.
It's a little bit difficult, but I'm hoping your followers are following.
Yeah.
I know it's technical, and I hope it's interesting to them because really it sits at the center of our existence. And I think it will bring technologies that will change the world fundamentally. And you know, I don't like using this sentence, but it will save the world. Like,
yes.
And it's not a saving thing because it's just a natural evolution of any societies. They eventually figure out how the electromagnetic fields works, and because it's easier, right? Because it's radiating out, so it's easier to understand. And then eventually they figure out how the gravitational field emerged from the foundation of the electromagnetic field, from this ground state of the electromagnetic field. And that's the second step of an advanced civilization, right? And then when they have that, they have not only almost infinite amount of energy available to them, but they have gravity control. So they don't need to be on the surface of a planet anymore. They can control gravity. They can make ships in space the size of planets if they want to, right? Because as soon as you can control gravity, all of a sudden you can do whatever you want. You can go to Jupiter for the weekend, you see? And that changes your consciousness fundamentally, right?
So then, yeah, so I think for the second part of this podcast, you know, now that we understand the universe in a deeper way, I'd like to go into, okay, so how does this impact an ordinary individual as they're on their own path of evolution and transformation, right? Like, so how does somebody who's listened to all this, hopefully kept with us in this deep understanding, had their mind blown several times like I have, and then how does this actually apply to an ordinary person? How does that change how they go about living their life?
Oh, there's so many ways. It's so incredible to understand this at the most profound level. I think that at least to start with a sense that you're part of something much, like you're not isolated, you're connected to this whole incredible mechanism of creation, and that you're like, part of this universal network thinking, that your thinking matters, that it's like one bit in the universal brain, if you'd like.
Yeah.
And that like you have your role to play.
Yeah, like someone said the sum total of all minds in the universe is one.
Exactly.
Right. But we're participating in the one mind.
That's right.
Uniquely as our unique participation, so that the universe is a seamless but not featureless, experience.
Like the trillions of neurons,
right,
firing in your brain, right? They collectively produce coherent thoughts, right? And all this. And so you can think, so to actually land that, to integrate that you're not isolated, that you're connected, that you're part of that there's a fundamental pulse of creation at the source of your existence. I think that's really profound. And there's many layers to that realization, there's many layers to, and to do that, like now you have mechanical equations. You know how to get there.
Right.
You have to go, instead of outside the event horizon, which is the radiative side, you have to go inside the event horizon, right? And it's not in an esoteric way. You literally have to integrate, which is really powerful for spiritual thoughts. You have to integrate your physicality. Instead of trying to separate, which is a lot of what this spiritual behaviors tend to do, instead of separate from the physical world, you want to integrate. You want to go inside, because that's where singularity is, right? So to start to experience yourself as 100 trillion cells, for instance, right? You think I'm one person, but I'm not one person. I'm 100 trillion cells. It's non-trivial, right? And every second I'm making millions of cells, right? Every second I'm dividing about 1 million cells, and there's billions of chemical changes occurring for me to continue to be here. And if that thing decohere, like I was saying, if you start heating up by a few degrees, it's not going to be good. If your blood plasma, change pH by 0.1 of a degree, 0.1, alkaline or acid, you're not feeling well. If it's going 0.2, you're like seriously sick and you're near death. 0.3, you're dead, right? So like this incredible thing that's happening, that's keeping you alive, right? This incredible organization that you're part of is keeping you alive. It's a pulse, so to integrate that at the biological level is one thing, but then if you go further and you go even further inside yourself and integrate that each of these cells is made out of 100 trillion atoms, now you've gone to the level in which you're like, you can start to experience yourself as like, photons of light emission and light absorption. And, you start to see yourself more as I think what ancient civilization described as the light being that you are, or, soul or whatever, but through the material world, not separate.
Hmm. Now, so the non-material entities, which, 25 years on the psychonautic path, I encounter non-material entities, and even the non-material entities of past living things.
Right.
In some way, I guess I could look at that as I'm accessing the memory of what was once a physical entity.
That's right. Very good. You're accessing the information of that entity continuing on its path. It doesn't. The information that cannot. This very clear principle of conservation of information in physics that show you can't lose that information when an entity set of information cannot be lost.
Mm-hmm.
So it's not limited to being in the physical. But you see, this is where we get in trouble with words. Mm-hmm. Because when I'm saying information, information in physics is equivalent to energy. I'm still talking about something physical, right?
Mm-hmm.
It's just not in the physicality of a body.
Mm-hmm.
But it's still an energy that cannot be lost.
Yeah.
And so it can continue on its path, and it's absolutely valid that it could reorganize into something that has a body.
Right, which is reincarnation.
Which is the concept of reincarnation, yeah.
And so this non-physical entity is not made of atoms at this point.
It's made of energy, and remember, I've shown that atoms is just coherent energy.
Right.
Right.
So it's coherent
energy.
It's coherent energy beyond the horizon of mass.
Right. Exactly. It's energy that's still coherent.
Yep.
But at a different state of density in the energy scales of our universe.
Yeah.
You see? And at that density of information in the energy scale of the universe, to you at this density, it appears like it's not there anymore.
Yeah.
You've lost communication capability with this information set.
Yeah.
Or you might have communication capabilities, but then people think you're psychic or you're, like,
or a channel
or a channeler or whatever.
Yeah, what's
right?
interesting about this is like these non-physical entities can impact my physical body. Like I can feel them when I'm in a journey. I can feel when these entities. I had this ayahuasca experience recently where this giant mantis being was like this massive interdimensional doctor who was going in and fixing things, and I could feel when it felt like light, but it was going inside my body, and like in ayahuasca they call them the doctorcitos, or this grand doctor that was just adjusting and manipulating the actual mass and field of energy in my own body,
right,
the etheric field and
right
in there. Yeah.
And we can do that to each other. This field of information, we control it.
Right, which is like the mirror neuron effect, the energy that we're sharing with each other that's impacting each other because we're all entangled
through this field.
Through the field.
Yeah, and we can so you're saying what is one of the impact? Well, when you understand the mechanics of this field, you understand the atoms you're made of and the information that is you inside these atoms is interacting with this field, then you can say, okay, well, I feel like my liver needs a little more energy, right?
Which is typically always for me because I put my liver to the test.
Yes, I understand.
I'm very guilty.
and you can direct this energy, and people that are good at directing this energy, which was well known by like Tai Chi,
Mana, Chi, Prana.
These people are called healers, right? Because they can direct this energy and help recover, from certain regions in your body that might start decohering because they're becoming separate There's a decoherence in that region of space.
And the coherence, it can become decoherent when there's a lack of energy, right? So there's one, Otto von Warburg has this metabolic theory of cancer, which I think is very interesting, which is saying that cancer develops from a failure of the mitochondria to produce sufficient energy.
Very good. And how does the mitochondria produce energy? Do you know?
The Krebs cycle? I don't know.
Yeah, but it's a little motor, electromagnetic motor that's spinning like a bat out of hell. The mitochondria has all these little motors that are separating electrons from protons and creating a potential, an energy potential. They're spinning at like 6,000 RPM if you're doing nothing. But if you're running a marathon, they're spinning at 60,000 RPM. These little motors. And in a marathon, you will recycle going through these motors, approximately a ton of ATP, which is the molecule of energy of your cells. And when these motors start to break down, they start not spinning as well and not spinning as fast and all this. They start, and by the way, they're doing this in water, right? So it's fluid dynamics. I want to remind you, right? And when they start to break down, then the cells start to make errors in its dividing. And this is literally getting old.
Yeah. So we're not actually supplying the sufficient amount of energy to keep coherence and keep things going.
It starts decohering so that it can reorganize at a different energy level. But knowing this, knowing that pulse that's making all this work is coming from the 0-point energy, you can, with the right technology, recohere the space inside your body so that this decoherence does not happen.
Or reverse the decoherence by improving the mitochondria. So one of the treatments that Travis Christofferson talks about, one of the treatments to support the mitochondria to produce more energy is restricted ketogenic diets, which actually allow you to get, ketone energy fuel and also rehabilitate the mitochondria along with hyperbaric oxygen. So you're packing in more oxygen, more energy that's coming from these oxygen molecules. Also breath work can do this. So you're packing the body with more vital life force energy, triggering an increase in vital life force, moving the mana. And then in that, the body as the miraculous healing capability that's possible. It's really about how much energy can you put back into the body? Whereas on the other side, it's like, okay, let's attack the cancer. And then you do all of these treatments, radiation and chemotherapy, which is sucking the energy out of your body.
There's a good chance it's going to decohere you to the point that, you've killed the cancer, but you killed the guy with it.
Right. And so there may be specific instances where this is important for this specific thing, but fundamentally underneath that, you have to be supporting your vital life force energy, which is about your thoughts, your beliefs, your connection to the field.
The information that you're moving through the feedback of your field. Exactly. When you talk about thoughts and beliefs and how you're functioning in the world, this is what you're sending in the field, and that's what the field is sending you back as your reality, right? This is the feedback I'm talking about. Like that is, you're in charge of that one. That's your job, right? You're not taking care of the 100 billion, chemical change that has to happen every second for you to stay coherent, but you have the responsibility of what you're putting in the field, your interpretation of the field, so that the field can feed you back what you can, the best experience, right? And so really that's really important to know. Like, you see, there's so many implications because there's remarkable things. There's all sorts of anomalies. You have people in India, and I've played with it. I'm just going to leave it at that. That don't eat. Like, there's a famous case of a guy that was studied by NASA, they put him in a chamber where they measured everything. The guy hasn't ate since he was 18. He was in his 70s, I believe, or late 60s when they did the test. Okay? The guy doesn't eat, doesn't drink.
So a breatharian.
Yeah, breatharian. Right?
And that's real.
Oh, absolutely.
Wow.
I've talked to the doctors that did the test. They were all mind blown, right? They couldn't believe it, and like they have like scans of his bladder filling up with fluids,
so the only thing that can account for that is, I mean, it seems like at some point he would have to replenish the water itself, though, right?
Well, that's what I was saying.
Because you eventually sweat, but
he stopped sweating.
He stopped sweating.
He stopped sweating. He was not sweating. We're
so
talking somebody in India.
If you put him in a sauna, he'd be fucked.
Maybe. I don't know. I don't know if they tried that. But the guy, and I mean, it's remarkable. But those are tests that were done by NASA and very serious scientists in India.
And the only thing that can account for that is this 0-point energy that we have access to.
Consider this. There is a problem in the current views of nourishment, meaning when you're recycling a ton of ATP when you run a marathon, do you really think that it came from the eggs and bacon you ate that morning? Right? I mean, I tend to believe, and, from personal experience, I don't need to discuss, but, that actually everybody is feeding off this fundamental pulse of energy at the quantum scale. And actually, the paper I'm about to publish in biophysics demonstrate the scaling that produce, the activity of the brain. But when you think of it this way, then you could say maybe I'm just supplementing, because when you calculate the amount of energy it takes to break down the food, get it into your blood, the glucose getting into the mitochondria, all this, and the amount of energy you're burning every day, it doesn't add up. It doesn't add up. So it's like there's a deficiency somewhere. There's another source of energy. Let's put it that way.
But at some point,
that is not rigorously done. And it needs to be done rigorously. I just want to put that as a caveat. I know that NASA did some tests. They made a suit where they could completely enclose, calculate all the energy the body uses and all this, which is it's remarkable. It's significant amount of energy. It doesn't quite add up.
It seems like, even in this case, let's assume that this case is true and this guy didn't eat from 18. It seems like for the growth necessary to reach the maturity of the body, he probably did need to supplement with different proteins in different particular forms. He did need to eat. A child needs to nurse at the breast, to actually build and grow. But once you reach a point of stasis, like this guy's not gaining weight.
No,
because that would require more supplementation.
But he walked every day a few kilometers every morning and every night.
So he was able to replenish the energy that he was burning from this alternative energy source.
Exactly.
That's really mind blowing. I always thought breatharians were just closet. But they just ate in a quiet secret and drank in a quiet secret place.
I'm sure there's some of those, but that's another thing.
I'm sure there's some of those.
Yeah, but
because it's the ultimate flex. It's like, what's your diet? Breath.
Yeah. Yes. But there's remarkable things. I mean, there is all kinds of organization now that are showing kids how to see without their eyes.
I've seen some of that. It's remarkable.
There's a thing called Viber Vision, a group of people in the US that are teaching that. There's people in India teaching that, all this. And it's remarkable. These kids literally, you blindfold them,
they can catch balls.
We've put censored in there, to make sure there's no photons going in, right? And make sure they cannot see, right? They cannot see. They have patches on their eye plus a mask and everything. and they read a book and they don't have to open it. It's fucking remarkable. Why? Because they're accessing information that's in the field, right? So
one of the key...
These are remarkable things.
Of course. And I think one of the key things that I've really... The reason why, and you're very generous in complimenting my mind, the reason why I believe that I have any intelligence at all is because I've practiced the art and actually the medicine lineage and technology of accessing the field. Like, so much of the information that I'm getting is from me accessing the field beyond me. So it's like, it just feels like a blessing that I'm able to create the bridge.
Yeah.
And it's, it has its own problems because then the bridge gets translated through it. I'm not always fully right, and things mature and evolve.
Sure,
But the accessing to this field of information, which is what allows all of these mystics and all of these ancient traditions to access information that was far beyond the comprehension that they have.
Yeah, consider that maybe all creative thoughts, all discoveries, they came. When Einstein was asked, where did you come up with this? It's like, it was internal, imaging and gut feeling and, like instinct. And, he said, like, himself, that instinct or imagination is more important than facts, right? Because that's the source. Now, eventually, you have to make sure that the facts work with what you came up with.
Right.
But where, creativity, where does it come from? It's an internal thing.
Or like the musical prodigies who can just sit down at a piano and play a concerto.
Right.
They're like channeling into a rhythm and a vibrational pattern and they're just able to translate that into music.
Right.
Or translate that, so many people who've had a dream and then come out with an entire composition based on this dream. You're accessing the field of information.
Of information. And I would suggest that your consciousness is exactly that. Is accessing the field of information, acting on it, your interpretation of it, and your action in the field produce a reaction from the field that we call reality. Right?
Yeah.
So it's really profound.
Yes.
When you start to connect at that level, it's really profound. And I want to say, it's typically not understood in its mechanics. And we can write the mechanics of such a thing. It's not outside science. It's not outside physics. It's not like another dimension. It's not like that stuff doesn't, it's all here. It's all one thing. It's not separate. It's one thing.
And that revelation, the revelation of the interconnectedness of everything, you realize that you can't do anything harmful to anybody else or a planet or anything else that is actually not doing harm to yourself. Right, course. Which creates a whole different set of morality.
Exactly.
In which you have to create a reciprocal balance and hopefully a net surplus where you're adding to life rather than subtracting from life.
Exactly. And so, people say, oh, but humans will always fight, will always kill each other, will always destroy. I don't agree with those statements. I think that humans, naturally, babies are peaceful.
Right.
Naturally. We've just been tweaked. We have so much trauma, like even just the first few seconds when we're born here, like the amount of trauma we experience. And so, but I don't think that's a natural state. I think that a society that understands these fundamental principles, and this is one of the reasons as well that I don't believe in, offensive, extraterrestrials, because I think that a society that reach higher level of awareness and understanding of the mechanics of the universe automatically arrive to that level where in this society, laws would not be required because everybody knows when they're doing good And everybody knows when they're doing something that's hurting others or hurting themselves.
And this is a place where personally I would potentially disagree with this. So I want you to follow me on this potential idea of entities or groups of civilizations that could actually be extractive. So if you reduce, and this is the idea of Ahriman from the Rosicrucian tradition, the idea of Ahriman is you look at the field of energy and through the eyes of Christ, let's say, the Christic impulse,
Yep.
you see the field as love and you see the actual in the interconnectedness. But if you reduce it to power, just power, so the field is just power, then you could create a morality in which power is the only thing that matters, and your goal is to accumulate the maximum amount of power for yourself. So it's service to self based upon a power dynamic. I want myself to have the most power possible.
Yeah, this is pretty well the state of our world right
This
now.
is exactly what's happening in our world.
Yeah.
And that could, and I think believe does, fractal up higher where there's, if we go the wrong way, we can create a world in which there's beings that are just reducing themselves to a hierarchy where there's ultimately one being.
Yeah.
So right now it's probably a bunch of elites,
Yeah,
but
it's
there's
like-
all the elites will compete and compete and compete until there's one being that accumulates all of the power and then has the right to extract energy from all of the other things. And that extends
that
beyond.
can happen.
Yeah,
I agree.
and I believe that has happened.
But it doesn't fractal up.
So there's a stopping point.
There is, because the system will self-destroy. The system will self-disorganize. Eventually, it's not sustainable. Mm-hmm. The nature of the universe is not so. So it's not sustainable. It cannot. A society like this will self-destruct. Right. Like, look at ours. In 150 years of, scientific evolution, we're on the brinks, right?
Well, it may self-destruct, but let's take, do you ever read Dune, or do you watch any of the Dune movies?
Yeah, I watched the Dune movies.
Okay, so imagine, you remember the Harkonnens. The Harkonnens are, what the House Atreides is fighting against, and they're this pale kind of homogenous, and they have a very clear hierarchy where the leader of the Harkonnens can do anything they want to any of the other people. Yeah. But there's an absolute top-down totalitarian domination model.
I understand what you're saying. The reason I disagree is because that's true politically or socially, you can do that.
Right.
But it will not lead you to technology in which you can go across the universe.
Right.
So if somebody's visiting from across the universe, they figured fundamental principles of creation. Mm-hmm. And if they have that,
then they understand that everything's connected.
They understand that whenever they do harm, they're doing harm to themselves. Mm-hmm. They understand that. If they don't understand that, they self-destroyed long before they passed their moon. Look at our society. We're on the brinks. We've barely passed the moon, and some people would, debate that. And so we, like us, for instance, going to, with this way of doing things where all the power is concentrated to a few individuals, we're about to self-destruct.
Right.
We wouldn't make it across the solar system, never mind across, to another solar system. Mm-hmm. We can't develop the tools and the understanding necessary using this kind of mentality. Mm-hmm. And so I don't see how an advanced civilization, like, for instance, let me give it in another context. Imagine you're a civilization that has gravity control and vacuum energy technology. You have pretty well all the energy you can ever need anywhere you are, right? And you can travel across the galaxy, let's say, or even, intergalactically.
Right.
In our galaxy alone, last century is about 40 billion planets, and that's very conservative. Mm-hmm. That's one galaxy. Let's say you have access to that. Why would you need, right, to take over the Earth. Right, for instance, right, which is a small
because you already
planet.
have access to infinite energy.
You have access to infinite energy, infinite resources. If you want gold, you have chunks of gold that are floating around that are the size of continent, right?
Right.
So you get gold, right? If you don't go and mess with the planet. If anything, when you go to a planet, you're gonna try to make it evolve faster.
Right.
You're gonna try to support it, help it flourish, because you know that more people, there is more viewpoints, there is more, the universe is growing, more viewpoints, more there's neurons in the system, right? So you want that to happen. So you're going to encourage that. And I would suggest, and this is just my opinion, but from the research I've done on this planet, that there is evidence that there was encouragement at one point.
No, I agree with that. I agree with that completely. All right, but let's say then you are in this service to self mentality, right?
Yeah.
And there's, just like our bodies, there's an entropy that naturally occurs where we're going to dissolve back into a different form. We're going to transform.
Yeah.
But what if we say, I don't want to transform. I want to stay as the entity that I am. And the only way that I can source that, I can't undo the force of entropy that's trying to dissolve me back into the all, which is perpetual life, is a beautiful process.
Right.
But if I can vampirically or parasitically harvest energy from some other civilization, some other planet, some other people, I can use that to supplement my own energy so that I can stay alive longer. And all I care about is that I stay alive longer, not that life exists.
Right. Right.
So do you think that to me is where I believe that this could go a little farther, is beings that are unwilling to transform? It's not,
you mean eternal life?
Well, they're unwilling to surrender their temporal form.
So there is on our planet currently animals that are eternal. So if you look up eternal animals, or if you look up, you will find, there's like jellyfish and actually lobsters. They die because their shell don't grow as fast as they do and all this. But jellyfish that can be eternal. If they don't get eaten by a shark or whatever. But, there's multiple species, not just a few, like there's quite a bit of them that are eternal. So the idea that cell can stay coherent and continue to redo themselves and, not lose energy and decohere is clearly demonstrated in our world is possible. Okay. But somebody that's doing what you just described would be, you have to consider what they would have to. So let me make it clear, because I don't want to be misunderstood. Do I believe you can make technology so that you can be immortal? Absolutely. What I'm telling you is that to get to that technology, you're going to have the level of consciousness.
Right. So there's no decoupling at the ultimate level of the consciousness with technology.
The universe is fail-safe.
Yes.
Civilization cannot reach huge level of like technology and completely destroy the universe, right? And be completely unaware.
Okay, but what about this? What about this scenario? So Stephen Greer, I don't know if you're familiar with his work. He's basically saying that in his belief that we've accessed the technology, just the technology, to be able to access the 0 point energy.
Yeah.
But the people in this, kind of deep state, world,
many inventors have.
Yeah, many other inventors have as well. But
most of them are dead.
Yeah. Like Tesla, and I think he was close to getting this, or maybe got it.
Right.
But we've somehow accessed unnaturally by recovered craft and by other different things, and kept that. And so we have access to technology that's beyond our consciousness. So there's a delta.
There's a gap.
There's a gap.
Yeah.
And so we could weaponize that technology because our consciousness hasn't caught up to understand the nature of it.
Yeah.
We haven't thought it through.
Yeah, you can reach certain levels this way, but then there's a limit to it, because when you go down that path of this advanced technology, eventually that technology is tuned to the same dynamics of feedback of the universe, right?
Mm-hmm.
The wheel of karma.
Yeah.
Okay. And so you're increasing in power, but if the technology you're using is tuning to your level of consciousness.
Yeah.
You can look at it, that feedback in the current technology. Our level of consciousness, not so high.
Sure, there's a delta right now between our technology and our consciousness.
Exactly. And the technology is about to destroy us because our level of consciousness, or how we're using it, is not so good.
Right.
And so basically, I mean, we're literally shooting at each other and killing children, and so with it, right? So, so this becomes, so it's self-destructive.
Yes.
Right? So this becomes very dramatic when the technology is like, for instance, a singularity in a crystal ball, let's call it, right? And it's in contact with your awareness, and you're trying to destroy with it. It will kill you. It will decohere you instantaneously. It's like the feedback now is like instantaneous. Instead of taking 10 generations, it takes 10 seconds, right?
Yeah, he also talks about, and one of the things he talks about
fail-safe.
is technology-assisted consciousness or consciousness-assisted technology, where actually the technology and the consciousness actually have to be linked. So the way that these crafts move is through accessing the field of consciousness. And if you're accessing the field of consciousness, you can't take it piecemeal. You got to take it the whole way. This
was best represented in fighter pilots. That, I think it was in the late 90s, 2000s, maybe a little bit later on. I was aware of this because, people talk to me that are from inside organizations. I'm just going to leave it at that. And the fighter pilots were too slow, reactive to the speed of the planes. Mm-hmm. And it was becoming a problem, and they wanted to explore how they can hook the control of the plane directly to the brain, right? With sensors and all kinds of things, and there is some of that in pilots. But there was a problem, because if the pilot had a bad day that morning, got in a big fight with his wife, whatever, something happened, they were emotionally not, like, the sensors would go off, the chart, and like the plane was bouncing all over the place, and, it was no good, right? And so they taught their pilots to meditate, so that they could like calm themselves and be be coherent and all this, and not have the sensor go off scales, right? Well, after they got the pilots to start meditating, daily, and meditation practice, and, all the things that go with them, eventually the pilots were like, okay, we're really good at controlling the plane, but we're not willing to shoot at people. We're not willing to drop the bombs, right?
Right.
We're like, because they reached levels of awareness, they're going, wait, I don't want to kill other people, right? You see?
Yeah.
See, it's linked. You can't decouple the two.
All right. So then what about the belief systems like Zoroastrianism, or even parts of Christianity, which say that in polarity, there's the force of good, life, expansion, the consciousness that we're talking about. And that's Ahura Mazda, which is like all things that are good, life, all of this love. And then there's Angrameño or Arman on the other side, which is the antithesis of that, and that there's these natural forces in the cosmos.
That's still all true.
Yeah.
That's still all true.
But we, as participating in a body, we're already on team life. We're already part of team, Team Ahura Mazda.
But think of it this way. Let's say our world got this level of technology, became enlightened and all this, and this planet became peaceful. Okay? That doesn't mean that there's not other planets in the universe that are at a lower level of evolution and haven't figured that out yet.
Yeah.
It's still happening. It's just that which side of the fence are you on, right? And it's not white or black. It's gray.
It's a gradient.
It's all grayscale. There's no perfect white. There's no perfect black. It's all grayscale. Like, it's where you are and the level of consciousness of your, collective. That's where you place in the grayscale of the universe between white and black. I don't believe in evil. I don't. Like it doesn't. It would be like darkness. Darkness is just the absence of light, right? It's not a thing, right?
No, yeah, darkness isn't the absence, but there could be something called anti-light, which would be the antithesis of light.
Right. And that would still be how anti-light are you? Like, where on the gray scale are you, right? So like, for instance, you meet people and you say, oh, they're more loving or they're less loving, or, like there's all kinds of scales of evolution. Right. And you might have noticed in your life, there's definitely jump. There's definitely like a horizon where you comprehend something, right?
Sure.
All of a sudden it lands on you. Oh my God. Right.
Yeah.
And then you got it. And then 10 minutes before you hadn't had it. Right. And then you got to integrate, and it takes time, but still, you can think that like a civilization collectively can all of a sudden integrate that we're part of a field, that everything we do in that field is interacting with everything, and develop and realize that like, oh wow, we're so interconnected. We need to be careful what we do, how we treat each other, and all this. Like, this can happen, especially if that comprehension is not just a spiritual awakening, but it's actually a physics awakening. Like, here's the mechanics on how we are all connected. Here's how it works. And here's the technology you can build so you can work on the interconnection of the universe. And so now you have infinite amount of energy. You can get any. So why would you fight for energy?
No, I get it. So I agree with you that there's no being that we know, especially incarnated being, that is absolute evil or absolute good.
Right.
But there's some. We're all participating in some scale between good and evil and there is, in any grayscale, there's the terminal point of that grayscale, which is absolute. If you're looking at just color, which is, I think a problem, but you look at it, there will be the point on the gradient of absolute light, call it the Christ. And then there'll be the point of absolute black, which call it Arman.
And you might fluctuate.
And you are somewhere in the dance.
Yeah,
but you're never going to reach absolute unless maybe you say, oh, Christ actually reached absolute. Well, you might reach absolute. I mean, the fundamental message of, I like to call him Emmanuel, as he's described in the Bible, was that everybody can get there. Right.
Like, that was the core of his message. You will do greater things than I did.
Yeah, totally.
Yeah, and so
that's the potential that he actually opened up in the memory,
in the possibility,
the memory and the possibility,
right.
Is he reached the potential,
right.
of absolute love.
And you might fluctuate, meaning you might be in that state one moment, and the next moment somebody cut you off on the highway and now you're flipping him off, right? Like,
and you even saw that transformation happen even in the Christ at the moment on the cross, where the first was, you know, why have you forsaken me? As he was talking, like, which is this moment of doubt and moment, and which was, and then he eventually forgave even the soldiers who were throwing dice to take his garments and his enemies who were crucifying him in the most horrible way. And so ultimately went out, you know, he exited, if you believe the story and the myth, he exited in purity.
In peace. Yeah. And that's available to you.
Yes.
That's available to you anytime. You know how many times people have done wrong to you, and you know it hurt and it was painful or whatever, but eventually you got to the place where, like, I bless them.
Love thy enemy.
I love them for the lesson I've learned, and you know, and I wish them the best, right? And so it's something that's available, right? It's not, and I think, you know, the masters come and they give us examples of what is possible, and typically they're the first one to say that's available to you. You know, you can do this. You don't have to venerate me. You can do it yourself. Like, you have access. They're the first one to do that. But then the people around them, typically after they're gone, start religions and all kinds of things.
And use that for their own, create power structures, etc.
Exactly.
Yeah. I guess for me, I fundamentally do believe that people can also, as we can access our potential for light, love, we can also access our potential for darkness or evil.
Absolutely.
Like Hitler was an antithesis of Christ to a certain extent.
But that decoheres pretty quick.
Yeah, it's massive destruction.
Yeah, that's massive destruction. And if they succeed, then it's the whole thing is gone.
The whole thing, it's a wrap.
Yeah, it's a wrap. And then let's say that the information is not lost, like we talked about before. Well, maybe they continue on another planet doing that until they get it, that like shooting yourself in the foot is not the best way to
walk. Which is why good always wins in the end.
Yeah, well, eventually it goes up the scale towards white. Hopefully.
Right. Well, it has to, because the other force is destructive by its very nature. And so if the universe is expanding, life is cohering in different intimacy patterns and complexities, you know, it must ultimately succeed.
Whatever doesn't work, it decoheres and reorganizes into something that works.
Yeah.
Yeah.
So this destruction is always a part of creation.
That's right. I mean, if you didn't have what we are calling the dark loosely, right, you wouldn't have learned anything.
Right.
So you fell so that you could walk, right?
Yeah. Your opponent is your evolutionary partner.
That's right.
Right. Yeah, I believe that. I believe that 100%, that the darkness serves the light. It ultimately shows us where we're decohering and invites us to a greater level of coherence and love.
This is literally those, I mean, loosely speaking, this is those correlation function equation that show that, like, overall you get a plus, right? You get more. And because you have to get the thing to keep spinning. It's going to continue to evolve, whether you're on the grayscale over there or you're on the grayscale over there. It's going to continue to evolve. You know, like whether Earth makes it through this little evolutionary moment that we're experiencing right now or not, it will continue to evolve.
Is there a point where the universe collapses back into a singularity? I've seen, like, because we think of the expansion that comes from a big bang at a Planck scale, you know, minuscule amount, that a burst of energy of infinite capacity. And again, you may have some alternate theories of that, but it always seemed like this was like breathing in a way, like the universe is going to expand, and then at a certain point it's going to reach its terminal velocity, and all the complexity is going to be reached, and then it'll collapse back into singularity and then expand again into a new, you know, universe.
I remember, if there's no center to hold it, it cannot exist, right? So when it's expanding, it's just because you're experiencing that part that's expanding out from it,
right?
But it's constantly collapsing at the same time. Remember, for every bit that goes out, there's a bit that goes in, right? So it's continuous
So that
expansion
and inhale and exhale is happening at Planck seconds.
Yeah, exactly. Or depending at which scale you're measuring,
or
sub-Planck, or proton, or depending at which scale you're measuring the inhale exhale, it's happening at that speed, at that scale. Right? And so then you realize, wow, it's just an infinite cycle. And that becomes really hard. When I figured that out, I was in a van. I lived in a van for 5 years. I was, in the desert in Joshua Tree. And I remember the moment very
Smoking the good stuff.
No. I
Just kidding.
I was very, very pure at the time. I hadn't, touched anything. But I was climbing every morning, climbing every night. I was soloist. And I really had this moment where I realized, wow, it's an infinite cycle, and I had to let go of a beginning. And I had to let go of an end. And that was hard. I had to stop, everything I was doing and integrate for a few weeks. I couldn't do any physics. I couldn't study. I couldn't do anything. I was just how do I let go of a start?
Yeah, it's the chicken and the egg koan,
yeah,
basically,
exactly.
right? It's
and then at one point I integrated, wow, it's just a beautiful, incredible cycle that I'm part of. And I can let go. And then my tension went back down, and I was like, okay, I can just be infinite in nature. Right? The information I am. I mean, that sounds all so esoteric, but I really impressed that it's coming from actually understanding the physics.
Yeah.
But it really is remarkable when you let go, because then you realize, wow, what an amazing process I'm in. Right? Just amazing, transformative world I'm living in that's constantly changing. We don't experience it so much because, for instance, we're making 1 million cells every second, but we don't see them being made, and we don't see all the cells we're losing. And so we just think of ourselves as some stable thing. Or we're on the planet flying through space at millions of kilometers a second, and we think it's all stable, and we don't experience the dynamics of the world we're actually, and the fragility of the world we're on. And so to actually realize that I'm part of this amazing mechanics of creation is very profound.
So then So I have another model that comes from my friend Matthias de Stefano. I don't know if you're familiar with Matthias de Stefano.
Yes, but I met him a few times.
He's a lovely man.
Yeah, sweet.
Yeah, really,
sweet soul.
Really love that brother.
Yeah.
So he has a 9-dimensional model of the cosmos, and in the 9th dimension, the memory is completely full, right? Every possibility has occurred in this, which is kind of impossible for us to imagine. It's infinity. It's an infinity of every possibility. All multiverses, everything, all the memory is full, and there creates a singularity event when the memory is full, because every different possibility has been recorded in the universe, and at that moment there's a singularity, which then cycles back into the first dimension of singularity again, which then restarts the process again.
Okay.
So what would you say about that?
Yeah, it sounds like he's describing the embedded bubble universe I was describing earlier. I don't like to use the word dimension, because it means something different to the physicist than it means to the spiritual people.
Right.
And so it gets confusing. But I think that first of all, I'd like to comment on one thing. It's hard to visualize infinity. That is true if you're trying to visualize infinitely big, and which is what people typically do. But actually, if you try to visualize infinitely small, because it's within you, you actually can get there. You can't, and as well, there's something that's really important about infinities that people don't necessarily realize, and that is that Cantor, which was an excellent mathematician that was really not appreciated in his time, came up with this, proved generally that that there can be an infinite amount of infinities. And I'm mentioning this, and I like to give him credit, but because infinities doesn't mean that there's no boundary. Infinities means that there can be infinite amount of boundaries embedded within each other.
Well,
you see?
Yeah.
And now you can visualize infinite amount of infinities. Because from any boundary you can divide to infinity. Right? But it's still a confined boundary. You see?
Yeah.
And and this is really what actually got me going when I was 10. I saw that because I was confused about dimensions. That the teacher taught me dimensions, and I didn't understand what he was talking about because he made a point and said dimension 0 doesn't exist, doesn't have volume. I'm like, well, there's a point. If there's a point, there's something.
Right.
So what do you mean there's nothing? Like, I was already lost. I knew I was going to fail that class for geometry.
There's this one thing that was shared with me, which is like a in some ways like a koan, right? So let's say you're imagining an arrow that's moving towards a target, and at a certain time, let's take half the distance between the arrow and the target. You take half that distance, half that distance, half that distance.
Yeah.
The arrow is getting closer to the target, but you keep going half to infinity.
Yeah.
There's eventually you could say, well, if there's still always half the distance, it will never reach the target.
The target.
How do you reconcile that? I've never been able to fully reconcile that.
I can't remember the name of that theorem. It's terrible. I'm having a senior moment, but so I excuse my lapse. But yes, this mathematically can be resolved. The arrow will reach the target, but conceptually, it's an important concept. Conceptually, the target, what's important is infinite amount of infinities. That is, even if the arrow has crossed the horizon of the target, it's still not touching anything. Because
there it is. There it is.
Because the molecules that makes up the arrow and the molecules that makes up the target are not touching. The atoms are quite far from each other.
I get it.
If you grow the atom of a diamond molecule, which is very dense, right? The densest material on Earth, to the size of an orange, the other orange in the same molecule is 2 football fields away. So there's a lot of space, right? And then inside the atom itself, there's the atom is 99.999999% space.
Yeah.
There's a little teeny thing in the middle we call the proton. This is what I've been addressing in physics, that makes up the mass of the atom. And all we can say about that thing is that in that region of space, there's a high density electrostatic field. We can't say really there's a boundary, or it's basically a field of density that we're describing.
So the arrow is infinitely penetrating the target at infinitely small amounts, which looks like it stops.
And eventually you would get to the Planck scale, right?
Yeah.
So this is basic concepts that at 10 years old I start to think, okay, so then physics must be singularized. I didn't understand black hole at the time. I didn't understand singularity, but I had this concept of fractality that made every point go to infinity. And I started to think, okay, well, how would the world work under these conditions? And that's what led to the physics I'm writing today.
That's what an epic story, and what an absolute pleasure it's been to sit here with you. If you had a message as we wrap up this conversation, which I very much hope we get to have more conversations. This has been just an absolute delight for me.
Thank you.
It's absolute delight. So if you had a message that you wanted to share to humanity right now, imagine this was broadcast to every single being on Earth, at least, imagining that other beings may not need this message, but if you're going to send a message to all beings of Earth, what would that message be?
Do not despair. There is incredible possibilities coming your way. There's incredible beauty, incredible, like you're an incredible being, part of an incredible, like, magical universe of infinite possibilities, and you have incredible power, and technology that's developed from that perspective is coming. And so participate, help that type of technology to emerge. And the world, will be what every human or most human have instinctively the sense that could happen, which is a utopian world where, everybody has enough or more than enough. And we can be in peace with each other. It is possible. It's just an evolutionary step we're going through right now. And all the information, everything is there for us to make this leap, to make this step. It's all there. Don't get discouraged, because it's easy to get discouraged. It's really easy. And you see people that are wonderful people, like, lose hope.
Yeah.
There's so much possibility. Yeah. It's so beautiful. Our future is so bright if we choose to go that route. And so let's choose it collectively. Make your part. Do your part. Not just in thoughts, not just in spirituality and development, self-development, but like get involved. Get involved at all the levels whatever excites you the most, for the collective, for the positive of the collective. And we will pull out of that this little moment in history so fast. It will spin your head. Like our kids will see an amazing world evolve.
Yeah, that's so beautiful. I think the phrase that's repeated in the Bible the most is "do not fear." And that means, have hope. Have hope. Do not fear. Never, don't let go of that. Like, do not fear. Like, there's a greater system. There's a greater thing that's driving this whole thing. Yeah. And don't fall victim to that despair, and go all in for all life and play our part. Yeah.
The concept of faith is not faith of an institution. It's faith of the universe. Have faith.
Yes.
That the universe didn't put us here for us to not have enough.
Yeah.
Right? Look around you. The universe is so energetic. There's so much energy. There's so much creation. It's so beautiful. Right? If you get discouraged, go in nature. Go and hang in nature. I live in the mountains. I go in the mountains and I just turn all the rest off and I go, oh yeah, I remember.
Oh yeah.
Oh yeah, I remember. This is a beautiful, beautiful universe with incredible possibilities.
Amen. Amen. Where can people go if they want to dive deeper and check out more of your work or research or, connect with you in any way?
People can go to spacefed.com. So it's the International Space Federation. It's in Geneva, Switzerland, and our laboratories are in France. And so at spacefed.com, you can get all the information, the papers, everything. We publish articles on science, layman articles on science, weekly, monthly. Get involved, become a member. You can buy bonds to contribute to our company and profit from our company eventually and all this. So like we need so much help. We need so much help. So please get involved. If you're interested, please help us. We need help. We need support because we're doing everything independently. And so it's really, and it has value. You know?
Absolutely.
So,
well, thank you for your work. Thank you for your contribution. Thank you for your spirit and your heart. And thank you for that message of hope.
Thank you. Important. Thank you so much for having me. It's so great to hang out with you.
I know. It's been an absolute pleasure.
Yeah.
Thank you so much, everybody. We love you. We'll see you next week. Thanks for tuning into this video. Make sure you hit subscribe. Follow me at Aubrey Marcus. Check out the Aubrey Marcus podcast, available everywhere. And leave a comment. Let me know if this video resonated or what else you would like to hear from me in the future. Thank you so much.